Okay, this video is about rational functions, how to find the horizontal and vertical asymptotes, horizontal and oblique asymptotes for a function, or vertical asymptotes or holes in the domain of a function. Okay, this is off the final exam review, number 44 and number 45, and I think I realized that I forgot to do 44 when I was sending out the key, so that's one thing I noticed. And also I noticed that this is a minus. I wrote this down wrong. It's correct on a review, it just wasn't right on this piece of paper. All right, so the first function, r1 of x, which is equal to x squared plus 8x over x cubed minus 16x, we are asked to find the domain, the vertical asymptotes, and the holes if they exist. So let's start with the domain. A good idea is to rewrite the denominator in factored form, because basically to find the domain, we have to say when would this function be undefined, or when would we be dividing by 0, or when would the denominator be equal to 0, because that's when you're trying to divide and that's when the function's undefined. So you could factor out an x here, leaving you with x squared minus 16. And then you could recognize this as being difference of squares, x squared minus 16, x times x plus 4 times x minus 4, and you could set that equal to 0 and say, okay, well, x is not allowed to be 0, it is not allowed to be 4, it is not allowed to be negative 4. Those are the three values that we have to discard. So the domain would be from negative infinity to negative 4, union with negative 4 to 4, union with 4 to infinity. That's the domain. It does not change no matter what else we discover about this rational function. Now, what we did discover is that we could factor the denominator. So let's factor the denominator into what we just discovered it would factor into. And let's factor the numerator. All we can do there simply is pull out an x, leaving us with x plus 8. Okay, now, here is what happens. If there is a common factor that you can cancel, and there is, the value that you got that it was not equal to, x equals to 0, that becomes a whole. If there is one, that is the equation of a whole. The other two values that we did not discard are where you get your vertical asymptote. So this function has a vertical asymptote at x is equal to negative 4 and at x is equal to 4. Notice that I wrote the equations of the vertical asymptotes and the equation of the holes, and that is what you will be asked to do as well. Over here for the rational function r sub 2 of x, which is number 45 on your final exam review, this is equal to negative 3x to the third plus 2x squared plus 5 over 2x cubed plus 6. In this example, we are only asked to focus on the horizontal asymptote or the oblique, or which is also called a slant asymptote. You find whether or not a function has a horizontal or oblique asymptote by comparing the degree of the numerator and the degree of the denominator. The degree of the numerator in this case is 3 because the highest power is x cubed. The degree of the denominator in this case is 3 because 2x cubed. In the case where they are the same, then you do have a horizontal asymptote. Y is equal to the ratio of the leading coefficients. So y equals to the leading coefficient of the numerator is negative 3. The leading coefficient of the denominator is 2. So y is equal to negative 3 halves is the equation of your horizontal asymptote. If you have a horizontal asymptote, then you will have no oblique. If you have an oblique, then you'll have no horizontal asymptote. And that is what these specific functions do.